Dear students, welcome back to our brand new channel. If you are in class 10 and wants to make your science preparation easy, interesting and exam oriented, then you are at the right place. Now in this video, we are going to start the very first and very important chapter of chemistry, that is chemical reactions and equations. So my children, have you ever given a thought, why do iron get rust? Why do food get spoiled? And why do crackers turn into bright and beautiful colors? So all are these because of chemical reactions. So in today's video, we are going to understand step by step what are chemical reactions, what are the types of chemical reactions, how to balance the chemical reactions, and most importantly, their effect in our life. So since this channel is very new, your support means a lot to us. So please do not forget to subscribe the channel so that you don't miss out on such videos and exam tips coming forward. With this, let's enter to the world of chemistry with chemical reactions and equations. Okay. So what all things we have in this particular chapter? So this chapter I have divided into 3 parts. Okay. So in the first part, we will be talking about chemical reaction. What do you mean by chemical reaction? What are the characteristics of a chemical reaction? Means how will you know the chemical reaction is happening? Then what is chemical equation and how to balance a chemical equation. In part 2 of the lecture, what we will understand? We will see about the types of chemical reaction. Okay, so there are 4 types of chemical reaction. We'll study about them, and in the part 3 we will study about the impact of this chemical reaction, that is corrosion and rusting. Okay, let's get started here. So when one substance gets converted to another chemical substance, we call it as a chemical reaction. For example, you have Mg plus oxygen, it gets converted to MgO. This is a different product, this is a different product, right? So what I call these things, these are reactants, okay? These are reactants and these are products. Okay, reactants and this is products. So when 2 things react to give you one product, a different product, then we will call it as reactants and products, and when reactants change to products, this process is called as chemical reaction. I hope this is clear. Now let's talk about how will you identify. Suppose you have taken Mg, you have added oxygen, MgO is formed, but how visibly, how by seeing you can tell that okay, a chemical reaction has happened. What all things can tell you whether a chemical reaction has happened or not? So whenever a chemical reaction happens, there are certain things that we find out. Okay, there can be either a change in the state, means liquid, solid, gas. There will be either a change in color, there will be evolution of gas, there will be change in temperature. So it is not that all of them will happen. It can happen, any one can happen, 2 of this can happen, 3 of this can happen, 4 of this can happen, but there will be some changes in these type of things, like change in the state, change in color, change in temperature and evolution of gas. Okay, these are the certain things. If you observe these changes, you can predict that there is a chemical reaction happening. Now we will talk about what do you mean by chemical equation. Okay, chemical equation means a symbolic way to represent a chemical reaction in forms of symbol and formula. So for example, if I say magnesium reacted with oxygen to give magnesium oxide, okay, this is a chemical reaction, but in equation what we have to use symbols. So for magnesium the symbol is Mg, for oxygen the symbol is O2, okay, and for magnesium oxide the symbol is MgO. So this is a chemical equation where I have written the reaction using the symbols. Okay, I have written the equation using the symbols, that is a chemical equation. Now we have the next thing, that is balanced chemical equation. So if you have the same number of atoms on both the sides of reactants and products for a particular element, if the number of atoms of the same is same on the reactant and product side, then we will call it as balanced reaction. Otherwise it is a not balanced reaction. Let me give you an example. If you see this particular reaction, magnesium, so if you see on the reactant side, right, on the reactant side you have 1 magnesium, right, O2 is there, so you have 2 oxygens. On the product side, if you see, what you will observe? You have one magnesium and one oxygen. So you can see the number of oxygen is different on both the sides. So this reaction is not balanced. So if I just write down 2 Mg and 2 MgO, if I just add these two numbers, now what I will see, on the reactant side I have 2 magnesium and I have 2 oxygen. On the product side I have 2 magnesium and 2 oxygen. So now this reaction becomes balanced. So whenever we have such type of reactions where the number of atoms of each element is different, we call it as a non-balanced reaction. And when the number of atoms of each element on the product and on the reactant side is equal, we call it as a balanced reaction. So let us solve this one particular question I have given you. We'll try to balance this reaction. This is H2 only, okay? The reaction is like this. So first see on the reactant side. So let me just write down reactant side, okay? And this side I have product, okay? So Fe I have 1 on the reactant side, Fe is 1. Then I have water, H is I have 2, oxygen is 1, okay? Then you have this side, Fe is 3, okay, oxygen is 4, okay, and again hydrogen is 2. Now what we have to do? So you can think that 3 Fe is there, right? So what I can do? I can multiply 1 3 here, okay. Now if I see oxygen is 4 here, right? So if I multiply 1 4 here, okay, then I got 4 oxygen, but that makes hydrogen 8, right? So then again I have to multiply a 4 here so that the hydrogen also becomes 8. Now let me write down the final equation. 3 Fe plus 4 water gives me Fe3O4 plus 4 H2. Now here you can see 3 Fe, 4 to 8 hydrogen, 8 hydrogen, 4 oxygen, 4 oxygen. So this reaction is now balanced, okay. So such type of reactions are called as balanced reaction. Now you can try to balance this 2 reactions. We will try to balance it, okay, just for practice. So first of all, let me write down, I have hydrogen, then I have nitrogen, I have oxygen, then I have calcium, okay. Okay, so hydrogen I have 1, okay, nitrogen I have 1, oxygen I have 3, and calcium I have 1, okay. So sorry, oxygen I have here, OH2 is there, means 2 oxygen, and here it is 3. So total I have 5 oxygen. Just let me check it. So here I have 5 oxygen, and then if I see, yeah, hydrogen, if you see here 2 and here 1, so I have 3 hydrogen, okay. So 1 hydrogen here, 2 hydrogen here, total 3. Nitrogen is 1, oxygen is 3, and here 2 it is 5, calcium is 1, okay, fine. Now coming to this side, this is on the reactant side. On the product side, what I have 2 hydrogens, okay, 2 nitrogens, and then I have 6 plus 1 7 oxygen, and I have 1 calcium, okay. Now let us try to balance this one. So what I will do is, since I can find 2 hydrogen is there, and NO3 group twice is there, so I will first try to make it 2HNO3, okay. So if I make this one 2HNO3, then what I observe, after I make 2HNO3, now what is the condition? See, you have to keep changing this one. So I have now multiplied 2 here, okay. So will it work or not? So this is completely hit and trial method, okay. You have to use different numbers and you have to try. So now if I multiply 2 here, I got 2 hydrogen here, 2 hydrogen here, so I have got 4 hydrogen, and then nitrogen I got 2, oxygen I got 6 here, 2 here, 8, and calcium is still 1. And on the product side, if you see, calcium is 1, calcium is 1, hydrogen on the product side is 2, okay, on the product side hydrogen is 2, nitrogen on the product side is 2, oxygen on the product side is 7, right, 3 plus here 6 and here 1 7. So if I multiply 1 2 here and also, okay, I am multiplying 1 2 here on the product side, so what will be the changes I will be observing? So if I multiply a 2 on this side, so again I have calcium 1, okay, nitrogen you have 2, okay, Oxygen you have 3 plus 2 6 and here 2 8. Oxygen is 8 and hydrogen you can see 4. Yes, so now you can see the number is exactly same. So that is my final equation, 2HNO3 plus calcium hydroxide, okay, that gives me calcium nitrate plus 2 water. Okay, that is there. Now we will move to the second equation. Okay, so you have to try this equation. So let me just erase this one. Okay, so by this time I am solving, you also try this question by yourself. Okay, let's do this question. So what all elements I have? First element I can find is sodium, then I have oxygen, I have hydrogen, right? Sodium, oxygen, hydrogen, then I have sulfur this side. Okay, okay, now what is the number of, on the reactant side? Sodium I have 1, no doubt. Oxygen I have 4 here, 1 here, that is 5. Hydrogen you have 2 here, 1 here, that is 3. Sulfur you have 1 here. Now coming to the product side, you have 2 sodium, okay, 2 sodium is there. Then oxygen you have 4 plus 1, 5, that is also balanced. Hydrogen you have 2 and sulfur you have 1. Okay, so now what I can find is hydrogen and Na is not balanced. So I have 2 Na, so let me try to multiply 2 Na here. Now let's see what is the change on the reactant side, because we have multiplied 2 here, right? So what changes on the reactant side? So if you see now, this one becomes 2 sodium, okay, oxygen here becomes 2 and here it is 4, so oxygen is now 6, okay, then hydrogen is 2 and 2, so hydrogen is now 4 and sulfur still is 1. Okay, now what I can do, you can see sodium is balanced, sulfate is balanced, sulfur is balanced. I can try to multiply 1 2 on this side. If I multiply 1 2 on this side, what happens on the product side? Let us try. What changes is there on the product side? So again I have 2 Na, right? Then I have 1 sulfur, oxygen here 4 and here 2. So oxygen I have 6 and hydrogen I have 4. So what is the final equation I have? 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Okay, clear? Fine. Now let's move to the next question, next topic, that is types of chemical reaction. So we have 4 types of chemical reaction. The first one is combination reaction. In combination reaction, what happens? 2 reactants react to give you one single product. A plus B gives you AB. One single product is formed here. So a reaction in which a single product is formed from from 2 or more reactants is called a combination reaction. Okay, you can see 2 different reactants were there and one single product is formed. Example, you can see many. Just a minute. So you can see carbon plus oxygen gives CO2, H2 plus O2 gives H2O, CH4 plus O2 gives CO2 plus H2O. Right, so these all are types of combination reactions. Now in combination, there is one more type of reaction that you should be knowing about, exothermic reactions. So those reactions in which heat is generated, okay, heat is given out, those type of reactions are called as exothermic reactions. And what will be the opposite of this one? The reactions in which heat is required, okay, heat is required is called as endothermic reactions. Okay, so this is a special type, exothermic and endothermic. In exothermic, heat is given out, in endothermic, heat is absorbed. Now coming to some examples of exothermic reactions. So respiration is an exothermic reaction. A question is often asked here in the exam, in your board exams, to explain why respiration is an exothermic reaction. So that is because the carbohydrates are broken down to form glucose, and this glucose combines with oxygen in the cells of our body and provides energy. So when the carbohydrate that you intake, that is broken down to smaller parts, okay, and then this glucose combines with oxygen and that gives you that gives you heat, or the energy is liberated. So that is why it is endothermic reaction. You can see this is the reaction of respiration. Okay, respiration reaction, this is very important, can be asked in the exam. So you can see carbon dioxide, water, and then energy is produced. So decomposition of vegetable matter into compost is also an example of exothermic reaction. Now moving to the next type of reaction is decomposition reaction, just the opposite of combination reaction. So if you see a single reactant breaks down to smaller products, that is called as what type of reaction? Decomposition reaction. Example, you can see FeSO4 breaks down to give you Fe2O3 SO2 plus SO3. Calcium carbonate breaks down to give you calcium oxide plus carbon dioxide. AgCl gives you Ag plus Cl2. AgBr gives you Ag plus Br2. Now here are certain things that you should be knowing, that what energy we provide here so that it breaks down. Okay, so if you see this particular, in this calcium carbonate gives you calcium oxide and CO2, we give heat energy. Heat energy is given. Okay, you just need to heat the compound. In this too, in AgBr and HNu, we give light energy. Okay, with the help of light energy, these molecules break down. There is one more example. H2O gives you H2 plus half O2. I can write like this. So here the energy that is given is electrical energy. Okay, clear? So different source of energy, but the processes that or the net information is same. Now coming to displacement reaction. Now displacement reaction is what? You have a compound with two elements, another compound B is there. Now B replaces one of this one. Okay, so what does this B do? It reacts with X and A go out. So we get BX plus A. Such type of reactions are called as displacement reaction, where one element replaces the another element from a salt or from a compound. Examples: Fe plus CuSO4. So Fe will replace this copper and you will get FeSO4 plus Cu. Next you have zinc plus copper sulfate. So zinc will replace this copper, you will get zinc sulfate plus Cu. Next we have lead plus copper chloride. Lead will replace this one, copper will go out, so you will get lead chloride plus copper. Okay, these are all displacement reactions. Now we will talk about double displacement reaction. Very interesting reaction. So in double displacement reaction, what happens? You have AB and CD. Now these two will combine and this two will combine. Okay, so you can see AD will combine and BC will combine. Means one cation of this one will replace the other cation of this one, and one anion of this one will replace the other anion of this one. Okay, so that is a double displacement reaction. Example, you can see Na2SO4 plus BaCl2. So what is the cation here? See, I am cation 1, means from here it is Na2 plus, and anion 1 is SO4 2 minus. Here if you see cation, sorry, oh 1 second, yeah. So if you see here, cation 2 is barium 2 plus, okay, and anion 2 is chlorine minus. Okay, so now what will happen? This cation will react with this anion and this cation will react with this anion. So Na will react with Cl, so Na plus this one, sorry, Na will react with Cl to give you NaCl, and barium will react with sulfate to give you barium sulfate. Right, that is the product. So the cation of one compound reacts with the anion of other compound, the cation of other compound reacts with the anion of the first compound. So that way this is called as double displacement reaction. Okay, now we'll talk about oxidation and reduction reaction. So very simple example of oxidation reaction is, what is oxidation reaction? Addition of oxygen. Okay, addition of oxygen or removal of hydrogen. Okay, similarly, what is reduction reaction? Reduction reaction is addition of hydrogen and removal of oxygen. Okay, so let's see here, oxygen is added, so it is oxidation reaction. Here if you see, oxygen is removed, so it is reduction reaction, oxidation, reduction. Here what is happening? Oxygen is removed, so it is reduction reaction. And here if you see, oxygen is removed, right? And if you see here, oxygen is removed here, and for water the oxygen is added, right? Oxygen is added here, is removed here. So in a reaction where both oxidation and reduction takes place, those type of reactions are called as redox reactions. Okay, moving to the next topic is corrosion, that is the effect of oxidation and reduction in our natural life. So first of all is corrosion. Corrosion is what? When a metal is attacked by substances around it such as moisture, acids, etc., it is said to corrode, and the process is called as corrosion. Okay, when the metal reacts with oxygen, moisture, acids present around it, we call it, the process is called as corrosion. Okay, so examples here is the black coating on the silver. When silver reacts with oxygen, it gets corroded. Green coating on copper, and the iron articles get a reddish brown powder on themselves. Okay, rusting of iron is very common phenomena we all have observed. So that is corrosion. Next is rancidity. What is rancidity? So when fats and oils are oxidized, they become rancid and the smell and taste changes. So you might have observed sometimes when you purchase some chips packet from not a very good branded one, you find some bad smell, bad odor of the oil. Okay, so that is because the oil present in this chips has got oxidized. This is called as rancid. Okay, now example, if I tell you, antioxidants are added to foods containing fats and oils. So to prevent this one, we add antioxidants around it. Okay, next we have keeping food in a airtight container to slow down the process of oxidation. So the oil should not come in contact with oxygen. And chips manufacturers usually use flush bags of chips with nitrogen. So when you have packets, you have the chips and that is flushed with nitrogen gas, so that the chips does not come in contact with the air or oxygen and do not get oxidized. Okay, so students, that was all about this chapter. Very brief and important chapter, but we have discussed it very concisely, and these all things, if you revise, you can definitely able to solve the questions, and I have brought you some questions that you can revise. The first question is, in which of the following the identity of the initial substance remains unchanged? So that means what? If the identity remains initially unchanged, that means it is not a chemical reaction. Okay, so the question is asking which of the following is not a chemical reaction. And for a chemical reaction to happen, what are the observations we have? We have change in temperature, change in state, right? The temperature may change, state may change. There will be gas evolution. Okay, there may be gas evolution. Next, what we have? Can we think any other thing? There are 4 points, right? Change in temperature, change in state, and there can be change in color. If any 4 of this is happening, or all the 4 or any combination, if any changes in this is happening, then we can consider it as a chemical reaction. So curding of milk. So in curding of milk, the smell changes, milk to curd, odor changes, color changes, so this is a chemical reaction. Fermentation of grapes, color changes, shape changes, so it is also a chemical reaction. Digestion of food, everything changes here, all the processes are almost involved. This is also chemical reaction. But in the formation of crystals by process of crystallization, there is no chemical change happening, it's a physical change. Okay, so that is why it is not a chemical reaction. Next, moving to question number 2, when aqueous solutions of potassium iodide and lead nitrate are mixed, an insoluble substance separates out. The chemical equation for the reaction is, so we have lead iodide, okay, plus lead nitrate, sorry, potassium iodide, my bad, just a minute, potassium iodide plus lead nitrate. Potassium iodide plus lead nitrate. So if I see, this is a double displacement reaction. So what will happen? So what are the ions? Cation here, K plus, anion here is I minus. What is the cation here? Pb2 plus. What is the anion here? NO3 minus. Okay, so what will happen? C1 plus A2 will form and A1 plus C2 will form, right? So what is C1? K A2. So I will have KNO3, right? And here I have A1 and C2, that is PbI2. Okay, so what is the final reaction? Ki plus PbNO3 whole 2 gives PbI2 plus KNO3. Okay, so what I will have? Ki. So which reaction? So we will balance this reaction. So I have I2I, so I'll make it 2. I'll make this one 2. Is the reaction now balanced? 2 potassium, 2 potassium, 2 iodine, 2 iodine, 1 lead, 2 nitrate, 2 nitrate. Okay, so I'll get 2 Ki plus PbNO3 whole 2 gives PbI2 plus 2 KNO3, that is option number B here. Now moving to the next question, that is 2-marker question. A silver article generally turns black when kept in open for a few days. The article when rubbed with toothpaste again starts shining. So why do the silver articles turn black when kept in open for a few days? Name the phenomenon involved. So we know that when you keep the silver articles outside, they react with oxygen, they get corroded, and this process is called as corrosion. Now name the black substance formed and gives its chemical formula. So let's see the answer. The black substance formed is silver sulfide. Okay, so sorry, the black substance formed is silver sulfide. So you can see silver articles turn black kept in the open because silver reacts with hydrogen sulfide gas present in the air. Okay, the gas is released in small amounts and polluted air, decaying organic matters and so on. So this is what you have to write in the exam. This process is called as tarnishing of silver. Okay, next, the black substance that is formed is silver sulfide, and here is the reaction. Silver plus H2S gives silver sulfide plus hydrogen gas. Let's see now question number 2. A substance X, which is an oxide of a group 2 element, is used intensively in the cement industry. The element is present in bones. So that element is calcium. Okay. Now a substance X, which is an oxide of group 2. So this element is calcium. So its what I can say, its oxide will be CaO. Right. This will be the oxide of calcium. On treatment with water, it forms a solution which turns red litmus blue. So now when this element reacts with water, okay, you will get calcium hydroxide. Okay, you will get calcium hydroxide. Clear? So now on treatment with water, it forms a solution which turns red litmus blue. Identify X and also write the chemical reactions involved. So let us see what all things we have given you, some extra thing also. So the X is calcium oxide, definitely quick line. Its preparation is definitely not needed, but I have given you so that you can remember this reaction. Okay, for answer this is not required. Next, you have within water when it forms a basic solution. So calcium oxide with water gives you calcium hydroxide, and that is an alkaline solution which turns the red litmus to blue. Okay, moving to the next question, question number another 2-marker question. Tripti mixes an aqueous solution of sodium sulfate and an aqueous solution of copper chloride. Will this lead to a double displacement reaction? Justify your answer. So what happens if I react sodium sulfate with copper chloride? Okay, so here I have Na plus SO4 2 minus, here I have copper 2 plus chlorine minus. So these two will react to give you NaCl, and this one will react with this one to give you copper sulfate. Okay. So now if this is the reaction happening, this is a double displacement reaction. So will this lead to a double displacement reaction? Yes. How will we justify? Let's see. Now see, yes, a double displacement reaction is likely to occur when Tripti mixes an aqueous solution of sodium sulfate and copper chloride. In a double displacement reaction, the cations and anions of two different ionic compounds switch places, leading to the formation of two new compounds. In this case, when sodium sulfate and copper chloride are mixed, the following reactions takes place. So you can see the cation and anion are exchanged. So that is why we will get a double displacement reaction here. Now moving to the 3-marker question. A metal nitrate A on heating gives a metal oxide along with the evolution of a brown colored gas B and a colorless gas which helps in burning. So let us see what is A. A is your metal nitrate. Okay, metal nitrate on heating gives a metal oxide. So when you heat this one, okay, you get a metal oxide. Okay, we get a metal oxide along with the evolution of a brown colored gas B, and you have a brown gas B. Okay, and we have a colorless gas, okay, that helps in burning. Okay, aqueous solution of A when reacted with potassium iodide. So when you have this aqueous solution of A reacted with potassium iodide, okay, forms a yellow precipitate. So what we get from here, we get a yellow precipitate. Okay, so now identify A and B. So where is B? So this brown color gas is B. You have to identify A and B and name the type of both the reactions involved in the above statement. So this is the first reaction and this is the second reaction, this one. So we have to name the type of this reaction and this reaction. Okay, so now let's see the solution for this. So now the metal nitrate A on heating gives you a metal oxide, a brown gas B and a colorless gas which helps in burning. So if you have learnt the reactions, you can easily guess this is about lead nitrate. So when lead nitrate is heated, okay, it gives you lead oxide, nitrogen dioxide gas which is brown, and oxygen, a colorless gas which supports in burning. So what is A here? A is lead nitrate and B is nitrogen dioxide, NO2. Now the second reaction is what? An aqueous solution of A with potassium iodide gives a yellow precipitate. So what is the aqueous solution? Lead nitrate plus potassium iodide. It will give you lead iodide plus potassium nitrate, 2KNO3. Next, the question is asking you what are these types of reactions. So the first one is because it is taking heat and breaking the compounds. So the first one is a thermal decomposition or heating reaction, and the second one, if you see, there is displacement. So this is a double displacement reaction. Okay, so we have given two reactions and this is there. So that is the answer of the given question. So here if you identify A and B correctly, you will get the marks, and if you write the two types of reactions correctly, you will get full marks in this question. So students, these are the important questions, topics from this particular chapter, and overall thorough revision of this chapter we have done. Still, if you have any doubt in this questions or any other questions you have, just put down in the comment section. We will definitely address to it. And the next thing is, as I already told you, this channel is very new, and we have started with a very good intent, a good motive to help all the 10th students around the around here. So please do subscribe the channel and show us your support. Okay, thank you so much and all the best. Keep studying, keep smiling, keep shining.